Alright, Facebook, our videos are always partial, so I decided to just make one on dome order. We do some for several companies behind closed doors. These are for the Banshee. This particular order goes to one company. We do it so they have to buy a bar at a time from us when we make their stock cylinder domes. So I figured we'd just be cool and make a process video, start to finish. So obviously there's the bar in the bandsaw stand. We start there with a 12-foot bar, and each of the pucks are roughly 2 inches. So the first step is just slicing up the pucks. We will go ahead and cut this puck, and then we'll move on to going to the lathe. .144 inches to a bar minus saw blade, 2 inches of puck. So you can see where that goes in a heck of a hurry. It's 70 domes, 144, 75, 77 minus saw blade. 144 inches to a bar. We want to divide it by 2 we'll give ourselves 50 thousandths for a saw blade. So 70 and a quarter domes per bar. They're sold in pairs, so 35 Banshees worth of domes. 2-inch puck. We have a setup machine for every set of jaws. Again, this is a stock Banshee. I've already set up all my tools in the carousel. This one little tiny bar does the O-ring groove on the spark plug boss. This bigger bar, I set the dome height all in one setup, so we'll start and do the top side of the dome. The drill bit for the spark plug hole. My coolant's low today, so I need to get coolant. And then threading bar. We do the threading a little bit different than most people. We single point thread bar undersized, then use a roll form tool to roll the thread into place. That's why our spark plugs always fit better, because they're actually a rolled thread, not a cut thread. So I simply load it. I've already done my setup. Close the chuck. We have a program already in here. It's on that program and it's in the memory, so it's a matter of hitting start and watching and making sure there's our start point. It'll be hard to see through the coolant, but as it is, here's the roughing cut. It set the face. Now it just set the outer diameter plus about 10 thousandths of an inch or so bigger. It's going to do the staircase. I'll pause it after this tool and open the door. It's just working down the backside profile. Again, we do these for 3 or 4 different companies. Here comes our finish pass. This particular company orders like this about 4 or 5 times a year from us, so we're able to work it in. Okay, that was the finish pass, and so we'll just pause it right there, and there's your dome. So our next step will be drilling the hole, and this is where I did plastic, and actually my coolant jet's plugged and I don't want to take the turret apart to fix it. So we're going to drill hot. Next tool change to the drill bit, back into place. I might have to stop it and blow it off. We'll see if it welds. I'm being lazy. I'm just kind of watching it. You'll hear it really change tone if it starts welding. Like that. It's gonna. Let's let it push. It's done. We're okay. So obviously, next step is a single point threading. So it's gonna drive single point thread like that. Again, it's threading a little bit undersized. I use a roll form tool to finish the thread. It rolls that rough cut over it and makes it the proper size. It's done single pointing. Now it's going to cut an O-ring groove on the neck because that particular style dome uses an O-ring radially around the neck, not on the face like the Dave Noss head or the Chariot head. And then this tool sets the install height. That's why my domes are always the same thickness. It's done in the same setup. I never touch it. It uses a grooving bar and sets that install height. Less setups, less room for error. They're always the thickness we want, plus or minus tool wear. And so when it's done with this step, that is the first step of 3 in the lathe, and then there's one more step inside the CNC machine to put the little notch in to locate the dome blade. So right now it's grooving deep, well into the combustion chamber area, again to set that flange thickness, all in the same setup. My domes don't run out, they're radially true. It's a good dome. We build them for snowmobiles, we build them for lots of guys. So there it is, the first operation done. Install height was set, O-ring groove is hiding in there. It's a big bore dome, so the O-ring goes at the outside of the dome. Like the Banshee guys know, it's already included. All the O-ring grooves, all the features relevant to that profile. And rinse and repeat 70 more times in the next two days or so. Alright, that's the process of making a dome. We'll follow this up with the other side because it's a 2-step process. And so I won't even do the other setup for the other side to take off this extra material and then profile it. I won't even do that till 70 domes from now. Alright, there it is, guys. Okay, Facebook, this is part 2, or an extension of yesterday's video on the domes. Whether I put them together or just add them up, either way. So, as you can see, we're completely on to something else at 7 in the morning. That's what I did yesterday with the domes. They're done. The first stop. Blaster heads are in the oven there. Hearst is doing his blaster heads. There's a pile of first stops to get done. I just thought I'd go through the setup real quick. We pulled out the tools for the first stop and have changed to a boring bar instead of the threading bar, and an automatic chamfering tool to kiss off the threads and make everything clean. These machines are old. There is no automatic tool touch off here, so the process is how we set up our machine and work. I have to go in and take off the work offset. Machinists will know what I'm saying. We have to take out all of our G54s and zero them, measure our tool, and then go put our G54 back. So that's the process for getting set up, installing and measuring the tools. Again, a spot bit for deburring the holes and softening the holes. The part off bar is usually always in that tool, a master tool in my turret. We're going to be using the boring bar. It's a solid carbide bar with a carbide insert. We can change. That's going to do all of our profiling, and also the counter bore of the dome. Each of these domes, depending on how deep the profile goes, needs the spark plug put at the correct location. And so that is one of the 3 steps I mentioned in yesterday's video. So again, we'll just go ahead and get measuring tools and get set up, plug all this together and make it one big video so that it's all inclusive when it's done, and you can see the entire process of a 2-stroke cylinder combustion chamber, a dome as we nickname it. Alrighty, I'll get these measured, we'll get going. So, we got all those tools set up and measured, and we're going to go ahead and go over everything real quick. Sorry, looking through the phone. Okay, get that up and out of the way a little bit. When I made these jaws, I designed these through evolution. This is like my 4th rendition since I've made these domes. And it's something I'm kind of proud of. Automatic chucks have a scale right there with a line. So, when I design these chucks, the raw stock is held like that. At the top of that scale, at the maximum of that scale. Then, without even turning anything over, my soft jaw holds the puck like that to do the profiling. That is actually a very lean setup to never even touch those jaws once they're put on the chuck for this entire process. Again, finally, after all this meat's taken off and I've profiled the bowl, the final step is to turn it back over and hold it by the dome again and do the counterbore accurately. So that is the step process in the 2nd and 3rd operations, and everything can be done off of that setup now because the machine offers, and I mentioned it a minute ago, the G54, 55, and 56. So this is the top side of the dome that you saw in the video prior. This is going to be the work offset setting for the bowl profile. And then when I turn that dome upside down again to counterbore it, this will be the work offset setting for that counterbore. So without ever even undoing the jaws, moving the jaws, or changing the concentricity of my setup, even though I turn the dome over twice, if I don't make a mistake putting it in the jaws, concentricity is held to tenths. Again, these domes are very, very awesome because of the setup alone. It's an older machine. A lot of guys have bar feet these days, but there are problems with the handoff between chuck to chuck that people never talk about. This is old, and man, this is an old, slow way to do it, but you can't beat it. Okay, Facebook. This is the 2nd op video. I did one describing a little bit of the setup. I'll choose whether or not I'm going to put that in or not. Pile of domes. We're going to do our 2nd operation. I'm going to hand the phone over to hers, and we'll just pause it in between steps. Basically, we're going to face off that hat section, which exposes what I discussed in the first video, and then we will switch to the boring bar and profile it. So after facing, I'll stop it. That's where I run up to. This is 15 thousandths in front of Z0. I run to 10 thousandths in front of Z0, so another piece of paper more over closer to the chuck. That's our clearance. Scary, scary, but that's where we run these. So first step, face off the hat. Next step, profile it. We'll pause in between steps and we'll go from there. Alright, here's the phone. Let's go over here. We want to go into automatic. We got our %100, program number 100. I'm proofing this. This is where I MDI'd the chuck to. So we checked our clearances manually first, no surprises. Total a machine if I smack that tool holder with that jaw. We broke the turret before, it's no fun to fix. Alright. We're just going to proof this into place. I'll shut the coolant off and use my feed rate dial. I'm going to stop right there at the first pass. It'll be a heavy hitter, so she's going to feed down right there. I'm happy with that. We're 275 thousandths in front of the chuck. So on the initial part of the morning, I do not see a mistake on my setup. It's always an act of faith, right? Cooling on, 100% feed rate. Here we go. She's eating. A little bit of a heavy hit on that one. 175 in front. I'm babysitting. 75 in front. I want to see that. So I paused the program, paused the coolant. Yeah. I believe what we got going on here. Okay, let's let her eat. Coolant back on. 100% feed rate. Off we go. we'll let it face. It's going to end at 10 thousandths in front. So right there's our last pass. We didn't smash the chuck, thank goodness. And we'll go back for a tool change. I'll pause it there. So if you buy a dome blank from us, that's how it will get delivered. That little bit of 10 thousandths proud is waste material. It's well inside the squish band area in that size of dome. And when a guy sets that up in his lathe and profiles it, same thing. The install height is already set. He can't get it wrong as long as he does not touch that face sticking out. Let me stop the chuck, give a better view. Sorry, grab the phone from hers. That 10 thousandths proud hat, that's just scrap material. The rest of it's set. So that's what makes this dome kind of groovy that way in my setup. Okay, so step 2. Looks like Skip's calling. We'll answer that in a minute. Back on with the spindle. Back on with the coolant. That proofs our location and everything, but I still watch a little bit. I watch my distance to go, and it happened fast, but I saw it as it was going. I'm used to this machine. I could see with my distance to go right here that I was okay. So now we are roughing the dome profile. This is a customer's request. I had nothing to do with the profiling or specifications of this dome. I make what I'm told in a very tight tolerance window, so the customer gets what they ask for. That was the roughing pass, and it's going to start in with the finish pass here. So pause, pause, pause. A little bit of fuzzies on there. My cutter's getting dull. Gotta be careful with them. They're always sharp. I do that daily. My hands are filleted. Okay. So there's your rough cut, your rough profile. Now it's going to come down and do a finish pass. So going on, spindle back on, restart the program, let it do the finish pass. Okay, the next is going to spot bit the spark plug hole, but there's the finished profile as machined. And then the spot bit is going to come down and just clean up the spark plug hole and make it a nice transition. No detonation, not a huge spot bit. That took a while to dial that in perfect, but again, we want to watch it. They come down fast and scary. A distance to go is 400 thou to the start of my lead in to my face. I can believe it. It's feeding really slow. This dome is an example of what happens if you don't have your height set. That tool went for it. It was scrap. That was from a long time ago, a month ago. So I've got it feeding slow because I'm watching my distance to go, but it still feeds slow. There's 100% feed rate, and she just kisses, and that finishes the dome. And so for the sake of just getting it done, I'm going to do it on this one dome, and then we'll move on because the way my setup is, it's groovy. Okay. There's my dome profile, but we still have to set the spark plug height. Again, if I didn't post the other video in between and connected in, I went on and on about how I milled the chuck jaws and made it all for the same setup without even moving the jaws on the chuck up and down. So the counter bore is as simple as gently reclamping. I already went through the work offsets, and we're going to bore the counter bore, so that is already sent over and in. So we're going to switch to program 200 real quick, and again I'm going to proof it, so the video is going to be redundant and won't be plug and play. Maybe I'll follow it with a second one without talking, I don't know, so you can see how quick it is. But percent 200 automatic mode, press start. Shut that coolant off, shut the feed rate down, watch distance to go, and make sure that I didn't make any mistakes setting up this morning and putting in my numbers. So right there we're coming in. It's leading up in the face, but it's 31 thousandths in front and it's in position, and I totally believe it. So I'm just gonna let it eat. So close the door, pull it back on, and 100%. And that's setting the spark plug height. And so basically that is the dome right there. I gotta double check the thread. Sometimes that counterbore lays the thread over. All that tool did was roll it back and chamfer it back with force instead of cut. So the final stage will be in the mill, because this isn't a live tool machine, to put the locating notch in that everybody has. Interchanges with Pro Design, interchanges with NOS, interchanges with Vitos, interchanges with Chariot. So it's a pretty universal dome. We've included some key features that make it not work in other domes and made it more universal. It will seal off this face if your head shell has that O-ring, or it will seal off that face if your head shell has that O-ring. It will also work in a stock cheater head as long as the install height and that height is relevant to Pro Design and NOS and Chariot. So that is basically the final test. I do it to every dome because stuff slides through the cracks and it's not a perfect world. There it is. The right length, the right protrude, unshrouding the face so the heat can give you the proper burn on the guys that are running alky. Of course, when you torque it down, that's going to come in the crust washer amount a tiny bit more. And Hurst will take this over, and every single series that we cut for our customer gets manual CC'd. So Hurst is going to actually take this over just like it is and go CC it and verify that we are right on point. And basically, if I include the notch, that will be the final step, but that is the process for making a dome. So I'll get all these videos edited together for a final one, but there it is.